Okay, everybody, so this will be a quick video that I guess falls under the category of reviewing, but it's something that you'll encounter on the next few assignments and probably the quiz. And it's how you simplify square roots. Okay, so what I'd like to do is give you a rule, and then we'll try to break down some problems based on this one rule. Okay, so what's the rule say? It says that roots can be separated across multiplication, meaning the root of a number that's a times b is individually the root of the number a times the root of the number b. See how I'm saying it separates? So you can do that with roots. Now, let's take an example that looks just like the rule. So what's the root of 4 times 5? Well, all right, just completely based on what I said up there, that's the root of the number 4 times the square root of the number 5. Now, the square root of 4, I happen to know the answer to that. Square root of 4 is a nice round number. It's 2. Okay? What about the square root of 5? Well, that's not a nice round number. We could get a calculator and we could maybe get a decimal for that. But unless the instructions say to do that, that's not what we're going to do. If the instructions say round your answer to so many decimal places, then we'll do that, all right? I mean, I could say root 5 is a little bit more than 2, okay? Makes sense. 2 squared is 4, so the number you square to get 5 would be a little bit bigger than 2. But unless the instructions say to round the answer to so many decimal places, we won't do that. So I'm just going to leave the root 5 alone because it's not a nice round number like square root of 4 is. So that's how we could reduce this. I got an answer for root 4. It's 2. I don't have a simpler answer for what root 5 is, though. So that's as far as we can take that one. Okay? Now, this looked just like that, didn't it? And I just wanted to show you something that was just like the rule that I started with. What about this one? What's root 20? 20 doesn't look like a times b. There aren't two numbers there. But couldn't we say 20 was 4 times 5 like this? Yeah, we could do that. I mean, it's true, right? 20 is 4 times 5. All right? And then we could proceed like this. So you see what I did here? I wanted to start with it that way because I wanted it to look like the rule. But, I mean, if you've got a number like 20, we can just factor it, all right? 20 is 4 times 5, and that's going to be individually root 4 times root 5. So, yeah, we'll get 2 root 5 out of that, just like we did up there. Okay? Now, there's my answer. That's how you reduce the square root of 20. Now, at this point, somebody could say, like, they could be thinking, and they could say, I wonder why we don't do it this way. Why don't we say 20 is 2 times 10? Is that true? Yeah, 20 is 2 times 10. That's definitely true. But say you took it further and you say, okay, this then is the square root of 2 times the square root of 10. Well, what's the square root of 2? That's not a nice round number. What's the square root of 10? That isn't either. It doesn't really get you anywhere. We don't get some whole number to come out of it, and that's what we want. Okay? So this is really just a dead end. Okay? So what we want to do when we see these is try to factor the number in a way that we get what's called a perfect square. Okay? And all that a perfect square is a number whose square root is a nice round number. So for example, 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. These are the list of perfect squares in order, and they go on, but, you know, what's the next one after that? That's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 49. 49 is a perfect square. So that's what's happening, all right? We want to factor our number in a way that one of the factors is a perfect square. Okay. So let's see a few other examples, help you get the hang of it. What about root 32? Okay, now that's not a perfect square. There's not a nice round number, a whole number that you can square to get 32. So what did I say? I said what we want to do is factor it in a way that one of the factors is a perfect square. So you think like, what's the biggest of these numbers that factors out of 32? You know, I'd say 16 is the biggest one on this list. We want to go for the biggest perfect square factor. And here's what I mean. 32 is 16 times 2. All right? True statement. 32 is 16 times 2. 16 is a perfect square. All right? So, all right, what did we say happens to this once you get it factored? This is individually the root of 16 times the square root of 2. The square root of 16 is a nice round number. It's a perfect square. It's 4, and so what we find out is root 32 reduces to 4 times the square root of 2. Okay? All right. So, see, I did that one like the last one. I got to find that perfect square factor, that biggest perfect square number that factors out. What about this one, root 75? What's the biggest perfect square factor of 75? In this case, it would be 25 times 3. That is a true statement. 75 is 25 times 3. So this is individually root 25 times root 3. Root 25, that's a perfect square. It's a nice round number. It's 5. The square root of 3 is not a nice round number. Okay, so that's where we leave it. Okay, now let's try something. You know, in math, you can almost always check what you're doing. Okay, so let's try something out. We're not going to round our answers unless the instructions say so, but I'm just kind of curious, like if I have my calculator, is there some way to check this? So if I type root 75 in my calculator, it tells me root 75 is about 8.66025, so on. Okay? I wonder if I type 5 root 3, if it will tell me the same thing. You see how these are equals? If I did everything right, this number should be equal to that one, even though it looks different. Let's try. 5 root 3. I'm going to type it in. 5 root 3. Calculate. Oh, look, I got the exact same number. Every digit's the same. It's exactly the same. Okay? So that's what you would expect if you were right. Those might look different, but they're not. They're the same number. Okay? All right. So that can happen in math. I mean, 1/2 is the same number as 2/4, but they look different, but they are in fact the same number. Let's do one more, okay? What about root 36? I hope you noticed something about that one. Is that one like this one? Or this one? Is 36 already a perfect square? Let's see. 32 is not, so we broke it down like this. 75 is not a perfect square, so we broke it down like this. 36, that's already a perfect square. Root 36 is 6. That's a trick question. I try to make sure that I catch you off guard and that you understood that when you got to it. Root 36 is 6. Why is that? Well, the square root of 36 is equal to 6 because 6 to the second power is 36. That's my because. All right, so this one's different than those, but you know, when you do math, the problems aren't handed to you all the same and ready to go. You might have to look at a problem and judge how to do it, and sometimes the way one is different than the one that you just did. All right, so do we see the difference between all these, and can we do them if we come across them again?